Now we're going to go through the solutions to the multiple choice questions on this review. When we take a census, we attempt to collect data from, you've got sampling, so that's sampling, and here is a census. So what is the difference between those? We get every individual in the population, and that is the difference between a census and a sample. Much more work, much more expensive to do, which is why we don't do them often. Number 5, you want to take a simple random sample, an SRS, of 50 of the 816 students who live in a dormitory on campus. You label the students 001 to 816 in alphabetical order. In the table of random digits, you read the entries. So here they are. The first 3 students in your sample have labels of, you need 3 digits to model 001 to 816. Since we're starting at 001, we should say we're going to ignore 000 and numbers greater than 816. We also want to ignore repeats because we don't want to survey the same student twice. So if I list out in groups of 3, I need 3 digits. Here, I just went ahead and did extra. This should be more than I need. And first of all, I can see I cannot use student 955 or student 929 because they don't exist. I have to ignore numbers greater than 816. Then you see I actually do have a repeat there. 769 is repeated twice. So my first 3 students are 400, 769, and 335. Number 6, a study of treatments for angina, pain due to low blood supply to the heart, compared bypass surgery, angioplasty, and use of drugs. The study looked at the medical records of thousands of angina patients whose doctors had chosen one of those treatments. There are 3 of them, as you recall. It found that the average survival time of patients given drugs was the highest. What do you conclude? Well, first of all, notice that we're looking at the medical records of thousands of angina patients. We're not getting volunteers or recruiting people to be in this study. This is an observational study because treatments were not randomly assigned. So D, is false because it says, we can conclude that the drugs prolong life because the study was a comparative experiment. But this isn't an experiment, it's an observational study, so D is false. We don't technically need a placebo since we're just trying to compare actually 3 existing treatments. Also, placebo might be unethical for a person with heart problems. You don't want to just not treat them, so that wouldn't be good. And B says this study proves that drugs prolong life and should be the treatment of choice. We never prove anything in statistics. If you see prove as part of the answer, that's probably not the answer. We can have evidence for, but we never prove anything. Part C says you can conclude causation. Well, it says we can't conclude that the drugs prolong life because the patients were volunteers. So in general, I want to make sure you understand that you can have volunteers for an experiment and you can conclude causation, all right? But this is not an experiment. So this has nothing to do with it. The patients weren't volunteers. They just grabbed their records. So E is correct. We can't conclude that drugs prolong life because the groups might differ in ways besides the treatment because this is an observational study. Number 7, Tonya wanted to estimate the average amount of time that students at her school spend on Facebook each day. She gets an alphabetical roster of students in the school from the registrar's office and numbers the students from 1 to 1,137. Then Tonya uses a random number generator to pick 30 distinct labels from 1 to 1,137. She surveys those 30 students about their Facebook use. Tonya's sample is a simple random sample because, one of the key aspects of the simple random sample is that every possible group of the same size has an equal chance of occurring, all right? So if that is true, you definitely have a simple random sample. Now, it should also have every individual has the same chance to be selected, but this can occur in other randomized sampling methods, which I'll show you after this slide. It was selected using a chance process. Other methods also use chance process, so that doesn't mean that this is a simple random sample. And other methods, such as systematic, don't use strata or clusters either, all right? So just because it didn't use strata or clusters doesn't mean that it's a simple random sample. You still have systematic. Then finally it says, it is guaranteed to be representative of the population. Samples are never guaranteed to be representative, regardless of how good the methodology. The random gods may be aligned against your sample. So A is the correct choice. So why isn't B the correct choice? Because that's the one you guys tend to get stuck on most often. Can other methods have equal chances for individuals selected? So here I'm going to make an example. We're taking a stratified sample of 4 students. We'll randomly select one each from 4 freshmen, 4 sophomores, 4 juniors, and 4 seniors. Now, there was a reason I made all those groups the same. So here are my freshmen: Amy, Brandon, Carla, David. Sophomores: Edward, Flora, George, Hannah. And you can see I just kind of went alphabetical, all right? But the main thing is I have 4 individuals in each of the strata, all right? Each freshman has a probability of 1/4 of being selected. Brandon, his probability is 1/4. So is Carla, so is David, and so is Amy. The same is true for the sophomores. There are only 4 in there. So everyone in this sample frame has an equal chance of being selected. Am I doing a simple random sample? No, I'm doing a stratified random sample. And it was possible for me to create a scenario where everyone had the same chance of being selected, even though it wasn't a simple random sample. All right, so every individual has a 1/4 chance of being selected in this example of stratified sampling. So now let's go to groups, all right? So what is the probability of selecting Amy, Edward, Ida, and Mary? Well, probability for Amy is 1/4, and Edward is 1/4, and Ida is 1/4, and Mary is 1/4. So I would multiply all those out, and I get 1/256. What if I did David, Hannah, Luis, and Paulo? Well, guess what? It's also 1/256. And you're probably going, hey, same probabilities, both are size 4. But what if I did Amy and David and Mary and Paulo? Well, the probability of getting that group is 0. You can't pick both Amy and David. Both of them are freshmen. You're only allowed 1 freshman. Same thing for Mary and Paulo. You can't pick both of them because they're both seniors, and you still need to go get a sophomore and a junior. So the group probabilities of size 4 are not the same. So although every individual has the same probability in the stratified random sample, not all groups of size 4 have the same probability. Number 8, consider an experiment to investigate the effectiveness of different insecticides in controlling pests and their impact on the productivity of tomato plants. What is the best reason for randomly assigning treatment levels, spraying or not spraying, to the experimental units? Farms. So we randomly assign treatments to average out confounding variables. If you remember the cow lesson that we did, you can have young cows and old cows, super healthy cows and unhealthy cows, fast cows and slow cows. And so we randomize so we don't have to do all the work on young and old and fast and slow. But the extra advantage is maybe there's still another variable we didn't think of, maybe dark colored and not dark colored, one color that blends in with the surroundings and one that doesn't. So randomizing helps to eliminate the ones we don't know as well. So not eliminate, let me be careful about that. It averages out their effects, all right? Because honestly, a faster cow is less likely to be eaten by a lion than a slower cow, right? Because they're further away when the cow comes around. So that effect still occurs, but if we have roughly the same amount of fast and slow cows in both groups, then, or 3 groups in that case, then we average out the effect. It does not eliminate the effect. So our correct answer is random assignment will tend to average out all other uncontrolled factors, such as, in this case, soil fertility, so they are not confounded with the treatment effects. So one farm may have better soil than the other. And in fact, odds are they don't have the same soil. Not exactly. Number 9, researchers randomly selected 1,700 people from Canada who had never suffered a heart attack and rated the happiness of each person. 10 years later, the researchers followed up with each person and found that the people who were initially rated as happy were less likely to have a heart problem. Which of the following is the most appropriate conclusion based on this study? So always you have to say, is this observational or is this an experiment? Well, this is observational. We did not force the people to have different levels of happiness. That would be a trick if we could. So we can eliminate choices A, B, and E. We can't use the word cause. So now we're just down to C and D. So one of them says people in Canada and one says people in this study. Well, we actually randomly selected from people in Canada. So we can infer to people in Canada, not just those in the study. So the correct answer here is C. Number 10, the sales force for a publishing company is constantly on the road trying to sell books. As a result, each salesperson accumulates many travel-related expenses that he or she charges to a company-issued credit card. To prevent fraud, management hires an outside company to audit a sample of these expenses. For each salesperson, the auditor prints out the credit card statements for the entire year and randomly chooses one of the first 20 expenses to examine, and then examines every 20th expense from that point on. Which type of sampling method is the auditor using for each salesperson? So we're randomly selecting a starting point from the first 20, and then we're doing every 20th. Hopefully you recognize this is systematic sampling. Works great for things like this where you're looking at a timeline, or any lines like lines to a cafeteria, people coming out of a store, people coming out of a polling place, anything where you have a stream either on a timeline or into a location. So that is systematic sampling. Okay, bias in a sampling method is, all right, so what is bias? Bias has to do with consistently overestimating or underestimating. Not doing both. You're either consistently overestimating or you're consistently underestimating, right? This is exclusive, or you're doing one or the other. And because of the method you used, right? So if you remember in Beyonce, if you did the activity, you would see that my students consistently overestimate the length of words because when they use their judgment to pick the sample, so that is a bias. So any difference between the sample result and the truth about the population that tends to occur in the same direction whenever you use this sampling method. Number 12, you wonder if TV ads are more effective when they are longer or repeated more often or both. So you design an experiment. You prepare 30-second and 60-second ads for a camera. Your subjects all watch the same TV program, but you assign them at random to 4 groups. One group sees the 30-second ad once during the program. Another sees it 3 times, so this 30-second ad 3 times during the program. The third one sees a 60-second ad just once. And the last one sees the 60-second ad 3 times, all right? You ask all subjects how likely they are to buy the camera. Which of the following best describes the design of this experiment? Well, it's not matched pairs because your individuals would have to be paired in some way, or you'd have to pair a before and an after, and that would probably be difficult in this experiment. It's not a randomized block design because that would basically mean separate experiments for different types of individuals, not treatments. For this, if you're trying to do the ad, maybe if you wanted to do a block design, you could say, oh, let me do, high schoolers, college students, young, just graduated, and then young marrieds and all that sort of stuff. That could be a randomized block experiment. But having different types of ads is really different types of treatments. The 2 things that vary are length of ad, all right, and the frequency of the ad. So that means we have 2 explanatory variables. So this is a completely randomized design with 2 explanatory variables. Can texting make you healthier? Researchers randomly assigned 700 Australian adults to either receive usual health care or usual health care plus automated text messages with positive messages such as, walking is cheap. It can be done almost anywhere. All you need is comfortable shoes and clothing. The group that received the text messages showed a statistically significant increase in physical activity. What does statistically significant mean in this context? So statistically significant means that the results are unusual. It's not what we would expect if our assumptions were true. If we assumed that getting an extra text really won't make a difference, we would not expect to see a big difference in activity between those who got the text and those who did not. So the differences in physical activity for both groups is larger than the difference that could be expected to happen by chance alone. Number 14, you want to know the opinions of American high school teachers on the issue of establishing a national proficiency test as a prerequisite for graduation from high school. You obtain a list of all high school teachers belonging to the National Education Association, the country's largest teachers union, and mail a survey to a random sample of 2,500 teachers. In all, 1,347 of the teachers returned the survey. Of those who did respond, 32% say that they favor some kind of national proficiency test. Which of the following statements about this situation is true? Well, I'm going to tell you the NEA does not like standardized testing, right? So 32%, not very many favored it, and that's what I would expect from the NEA. They're constantly complaining about standardized testing. So I think you have an issue that this sample is not representative because it's just the members of the NEA, which is a teachers union. Not all teachers are members of teachers unions. Some teachers choose not to be a member of a teachers union, or at least try to avoid it. In some cases, you can't. Okay, so we have an undercoverage here because we're only surveying people who are members of teachers unions, all right? We are not surveying other teachers who are not in teachers unions. So that's undercoverage. All right. Then the other fact is only 1,347 of these people returned, oops, here we go. Fell asleep on me. Only 1,347 out of 2,500 responded. So that means we have a large non-response bias. Lots of people just kind of pitched the survey in the recycling, or they just deleted the email. However they sent it out to them, most of them didn't respond. So this sample is likely not representative as well. The only kind of people that are going to respond to this survey are people who feel strongly about the topic at hand. So the answer is the results of this survey may be affected by undercoverage and non-response. Good luck on your test.